Hi everybody, we are going today to present our simulation of a culvert presented by HY8. First of all, we should begin the software, execute the software, and then we click this continue, and before that we should choose the SI units metric, the unit. We could choose the US customer units, but it's more interesting to choose the SI units metric. And then we click here, new culvert crossing. We should now define our crossing, our river, its characteristics, and its geometric data. We could name this river with this name, river crossing is more interesting, crossing tutorial, and then we are going to fill this table. First of all, the discharge data, minimum flow is 0, design flow is 118, maximum flow is 360. The tailwater data, the channel, it's in this example we are going to present an irregular channel, and its characterizing points are calculated through an Excel sheet. This is our cross section. After calculations, we could define the x-axis and the elevation. For the x-axis, we or the stations, it's 1.1, 4.2, 34.4, 37.5, and 38.6. Define, yes, we have 6 characterizing points, and the slope is 0.0125. yes, and by using the Excel, we could then copy our data. But we should mention that the irregular tailward channel, this section corresponds to the downstream culvert section. In other words, this is our river, this is our roadway, this is the crossing, and the culvert is corresponding to the crossing between the river and the roadway. So the length of the culvert should be upper than the width of the roadway. For example, if the width of the roadway is 5, the length of the culvert should be 8, 9, for engineering reasons. For that, the station here is the downstream station. This is our culvert. This is our culvert, and this is the outlet of the downstream section. So this downstream section is the section that we should fill in this table. After calculation, what are the calculation? For example, this is the section 4 with an elevation of 2.6375, and we have the distance between the section 4 and the upstream or the inlet section of 100 meters, and we have a length of the culvert of 11 meters. Then, after calculations and using a slope with 0.0125 meter per meter, we can calculate the elevation of the outlet and the distance between this section 4 and this outlet section, which is 111. And after calculating this distance and these points, these characterizing points, which are here, we can copy and paste it. Use the Ctrl C and Ctrl V button, and we copy them. Manning N. This is our Manning, number of Manning of the channel. 0 point. We copy, paste, etc. Okay, we can plot and view our section, which is the same as here. Okay. Now we pass to the roadway data. The roadway profile shape, constant roadway elevation. That means that the roadway here in this sheet, the roadway, this is our roadway, its constant elevation. Its elevation is constant through the crossing. First roadway station, it doesn't matter, we will choose it 0. Crest length. This is very important. The crest length. What is the crest length? The crest length is the width of our channel. Okay, it's the width of our channel, which means it is in this example it is 38.6. The crest elevation, it's important. The crest elevation is the elevation of the road. Here we have the road. This is the road. This is our culvert, and for engineering reasons, we should optimize for distance between the roadway and the culvert, an elevation that would let us avoid accidents or the water that would probably cross our road. So, for example, we could choose this elevation of 7 meters, because I will demonstrate it, because this is the upstream section of our culvert and this is the downstream section of our culvert. The highest elevation is 5.5875. 1 meter, 0.5 or 2 meters could be security, could be for security reasons. Then because the water, when we choose a high flow, the water could access to the road, so we must choose a distance that we could call it a security distance. Yes. Then paved the roadway. We have achieved our first part of the filling the table. Now we pass to the culvert. It isn't difficult. Excuse me, the name culvert 1. Okay, shape circular. We have different here. Excuse me. No. We have different types. I will choose the easiest one, circular. Diameter 4 meters, which is 4,000 millimeters. 0. We can we can access to the help, and we could know more about the software and the characterizations of the software. Manning, here is the Manning. It's 0.0155. Excuse me. 0.0155. The culvert type here, if we are going to use square edge with head wall, or we aren't going to use a head wall. And then the side data inputs option. The side data, it's very important, this part. The Intel station, as I have mentioned, we have this section 4. We have the Intel station, the upstream section, and the outlet, the downstream section. For the Intel section, which corresponds to an elevation of 1.388, calculated here. 1.388 here is the low chord of our section, of our upstream section. This is, and this station, the distance between section 4 and the inlet station, which is 100 meters. So we put here 100, the Intel elevation 1.388, the outlet, the downstream, the distance between the section 4 and the inlet section, which is 100 meters, and the distance between section 4 and the outlet station is 100 meters plus 11 meters, which is 111 meters here, 111. And the outlet elevation is 1.25. After calculations, it's not difficult. We have the slope and we have this distance, so it's very easy to calculate this elevation and this elevation. Now we pass to the number of barrels. In this example, I will choose 5 barrels, and then I have finished the data. Analyze crossing. I have an error here. Roadway top width must be greater than 0. Roadway top width. Yes, I have forgotten to fill this case. The top width. What is the top width? The top width is the width of our road. Here is our road. I would choose 3 meters for each lane and 2 meters of security. Then if we have a road of 2 lanes, then we have 3 multiplied by 2, which is 6, plus 2, 8 meters. Our road is 8. Our road's width is 8 meters. And now we analyze crossing the culvert. Yes, analyze crossing. Excuse me. Yes, we have here the table that describes our flow and our crossing rating curve, and this is the famous curve, which is the rating curve, the headwater elevation, and the total discharge. The culvert summary, we have here the headwater elevation, the total discharge, the outlet depth, the tailwater depth, and this is the velocity, which is very important, the velocity. And then here in this figure we can see the water surface here before attending the culvert and after attending the culvert. This is our work today for the HY8. It is not difficult, as we can see here. We should fill the table correctly and answer the right data, and then we could visualize the results here. Water surface profiles here. This is total discharge. This is a culvert discharge, which is the same for the most of the profiles: the headwater elevation, the inlet control depth, the outlet control depth, the flow type, the length full and the length free, dropped and customized depth. This is HY8 for amateurs. Yes, I will save it. I will Mahmoud, for example. And thank you for watching this tutorial. For any assistance or help, I would be very happy to help someone who has difficulties with this software. Thank you and have a good day.